So in geometry, there's this myth that most of us take for granted, and that's that all angles in a triangle have a sum of 180 degrees. And this myth is not true, okay? And you might say, hey, Andrew, but there's a proof on this. And you're right, but that's because your scope of geometry is limited to 2 dimensions, okay? And when we think of geometry, we think of a width and a height most of the time. So when we're drawing a square, for example, we say here's a width and here's a height. When we draw a circle, there's a width and there's a height, and that may not be on the same terms of a finite length or a rational length. We still think in terms of a width and a height. But I think that's the wrong perspective of geometry. I think we should take a more third dimension take on it. And when you look at the third dimension, you see why not all triangles have a sum of 180 degrees. All right, and let's take a sphere for example. This is what we call spherical geometry, by the way. So we have a sphere. Let's just call this a sphere for now. We have lines running in 3 dimensions, right? So here's the line going from the back, and here's a line going through right here. Okay. So we have spherical geometry like so. And if we say Earth, for example, Earth has a longitude and a latitude, right? The latitude, let's say the equator and longitude lines go across like so. And once we start drawing lines on the longitude and latitude, and we make a triangle, if we draw a triangle on the sphere's surface, we can see why the triangle has angles greater than 180 degrees. And Wikipedia has a very nice example of why this is true, right? So we have a sphere right here, which is Earth, okay? And we have longitude and latitude lines. We have a longitude going here, we have latitudes going like this. And so we take our pencil and we say, hey, we're going to start right at the North Pole. And if we start at the North Pole, we're going to go down our longitude lines like this. And then let's say we're going to stop right at the equator. All right, and the equator is perpendicular to all other longitude lines, right? Just like how all latitude lines are perpendicular to longitude lines, the equator fits that group, okay? So we're going to stop right at the equator, and then we're going to start moving across this latitude line. Then we're going to stop at some other point, then we're going to move back to the North Pole. And you see that we have two 90-degree angles right here once we stop at the equator. And 90 plus 90 is 180, but then we also have this extra 50-degree angle. And this 50-degree angle is going to make our triangle equal to 230 degrees, which is greater than 180. And that right there destroys our myth of saying all angles in a triangle equal to 180 degrees. But there's also another way of proving that all triangles, the sum of all the angles in the triangle equals to 180 degrees, and that's if we use hyperbolic geometry. And I'm going to go ahead and erase some stuff. Erase. It's taking a pretty long time. Eraser's kind of small. Alright, so we got our eraser, okay? And now let's look at hyperbolic geometry. And hyperbolic geometry is just, when we curve around these 2D planes and look at some cones. All right. So let's curve around our 2D planes. So let's say I have a flat piece of paper like this. Okay. And I'm going to draw a triangle on here. I'm going to draw a triangle. Let's say I'm going to draw the triangle like this. Okay. And this looks clearly like it's 180 degrees, right? It's on a 2D plane. All of these are 180 degrees. Now let's take our same paper and let's curve it around, all right? So let's physically bend the paper, right? Imagine yourself bending a piece of paper. And if we bend this paper, I'm going to try to draw that out. If we bend this piece of paper, all right, drawing it a little bit larger. So if we bend our piece of paper like this, all right, physically bend it, let's say right across this line right here. And then we're going to draw this invisible line right here just to show that there's paper running through the back. Okay, if we physically bend the line like this, we're going, and then we try drawing that the same exact line or the same exact triangle, we're going to get something like this. Alright, because we just bent this piece of paper and we're going to try to draw another triangle on there. And if we try to draw another triangle on there, we get something that looks like this. And this does not look like 180 degrees. These are three tiny acute angles that will be less than 180 degrees. Alright, and that will also uh, disprove this statement that all triangles have a sum of 180 degrees. All right. So we have two ways of disproving this. We have our hyperbolic geometry, and we also have our spherical geometry right here. All right. And so what I want you guys to take out of this video is that not only that, is this a misconception? Also, I want you guys to think of geometry in terms of three dimensions, all right? Not just 2 dimensions, not just 1 dimension. Think of it in 3 dimensions, and once you do so, you'll have a new perspective on how to not only solve geometry problems, but just a new perspective on geometry altogether, all right? And so I really hope you guys found this last video helpful and interesting, and yeah, that's the proof.